Question number 41. In a connected graph, the total number of branches is B and the total number of nodes is L. Then the total number of links L of the co-tree is. So here what is given, number of tree branches or twigs, which is also called twigs, is given to be, number of branches is given B. Number of branches given B, total number of nodes is given N, then total number of links of co-tree is. So number of tree branches or twigs is equal to n minus 1, that is number of node minus 1. So number of co-tree branches will be number of co-tree branches is also called links or chords, and this will be b minus n minus 1, that is number of branches minus number of twigs. This will be b minus n plus 1. So here answer will be option D. Next question is 42. The row formed at a node A is the chord-set matrix in the following figure is. So here we have to form chord-set matrix. Here A is a chord-set matrix, means we have to separate a node from the rest part of the graph. So what we will do here, we will delete or we will separate this one like this. We will separate like this. So what will happen? Here I am changing the color. So here what will happen? This one is the chord set. We are separating a node from rest of the graph. And how I can write the row? So what are the connecting branches to node A? So what are the connecting branches? One is here. If I remove this one, here is 1, this branch, another is 5, this branch, and another is 8. These three branches are connecting to the node A, and these three branches will define the row for the chord-set matrix. So how we can define that one? We will separate like this, and in the direction, what is the direction of A? Direction is this direction. In this direction A is present, that is chord set is present in this direction. So if the orientation of the branch is in same direction that in the chord set, so this will be positive 1. And if the branch direction is if the orientation of the branch is in the opposite direction, then this will be minus 1. Here I have written, if the branch is not connected to the chord set portion, then this will be 0. So what are the connecting branches? Only 1, 5 and 8. So we have to take tension about 1, 5 and 8. So here I5, I1, I5 and I8. These things we have to remember. So what are the directions? Here if we consider 1, here this one is 1 branch and direction is this, orientation is this. That means the same as the orientation this one, So what will be this one? This one will be positive, this one will be positive plus 1, this one will be plus 1. Next is 5 has also the orientation same as that of orientation of a chord set, so this will also be plus 1. Next is 8 is also in the same direction, so this will be plus 1, and other rest currents will be 0. So here option B is the correct answer. Suppose I am changing this one. Like suppose 5 has direction this, like this, downward from A to B. So what will be the chord set matrix? This will be plus 1. 5 has, this will be minus 1, and this will be plus 1. So this is the chord set matrix and the row. Next question number 43. What will be the number of trees if the graph exhibits reduction in the form of reduced incidence matrix given below? So this A is given here is the reduced incidence matrix. So what is incidence matrix first? Incidence matrix has order n cross b, that means number of node cross number of branches. So what is the order of reduced incidence matrix? that is n minus 1 cross b, n minus 1 cross b. So why here n minus 1? We have omitting one node by taking that node as the reference one. So here n minus 1 cross b. So here what is the order of this matrix? The row, first row, second row, third row. 3 cross 1, 2, 3, 4, 5, 6. 3 cross 6. So n minus 1 cross b is 3 cross 6. 3 cross 6. So here n minus 1 is 3. So what will be the n? N will be 4. So what will be the incidence matrix order? 4 cross 6. So number of tree, what is the formula for number of tree? For number of tree is n to the power n minus 2. Number of n is the number of nodes. So n to the power n minus 2. So here 4 to the power 4 minus 2. 4 is the number of nodes here. So this will be 4 to the power 2. That means 16. So here answer will be 16. That means option A. Option A is the correct answer. Next is, how many fundamental chord sets will be generated for a graph with n number of nodes? So fundamental chord set is fundamental chord set will have one tweak and minimum number of links. So what will be the number of nodes? Number of nodes will be n minus 1. Simple, n minus 1. How many fundamental chord sets? Fundamental chord sets will be n minus 1. Next question is, Vi characteristic of an element is given in the figure below. So what type of element is this? So here in first quadrant this is linear, but in the second quadrant here the slope is positive, but here the slope is negative. As the slope is negative, that means this is active one. This is active element. So first thing is this is active element. So what are the options? Here this may be true, this may be true. So this may be also true. First thing, the next thing is it bilateral or unilateral? If this is bilateral, then the third quadrant will be the mirror image of first quadrant. So what will be the third quadrant? Like this. If it is bilateral, suppose first quadrant is like this, then second quadrant will be like this. This is non-linear bilateral, but as there is no third quadrant part, this will be non-bilateral or unilateral. So where are the non-bilaterals? Here. And as this one is linear in the first quadrant, I can say that this is also linear. So generally linear are both in first and third quadrant, but here only first quadrant is given, but we can select the option by active and non-bilateral. So option B here is the correct answer. Next question here is question number 46. Consider a delta connection of resistors and its equivalent star connection as shown below. If all elements of the delta connection are scaled by factor k is greater than than 0, the elements of the corresponding star equivalent will be scaled by a factor of. So here delta connection is given and we will change each element by multiplying k. So here this will be KRA, here this will be KRC, and here this will be KRB. So what will be these values? So here from delta to star, how we are converting from delta to star? Suppose this one is the star element, capital A, as here given. Capital A is the star element. So star resistance is given as RB into RC. These are delta resistors, RB small b into R small c by RA plus RB plus RC. So when we multiply k to each element, in the denominator we will find k square, because here RB and KRB into KRC, here this will be k square into RB into RC. Then in the denominator KRA plus KRB plus KRC, we can take common k. So this will be in denominator, there will be only k. So what will be the result? Result will be k multiplied by the previous result. So the star connected will have the elements multiplied by same value, that is k, same value, that is k, not k square, not 1 by k, not root over of k, only k. Next question is 47. Two incandescent bulbs rated respectively as P1 and P2 for operation at a specified mains voltage are connected in series across the mains. Then total power supplied by the mains to the bulbs are. So here first bulb is P1, second bulb is P2. They are connected to a specified mains voltage. Suppose we can consider here, suppose 60 watt bulb and 40 watt bulb, both are connected to 220 volt supply connected in series. So here I have solved this one. Suppose for first bulb 1 is rated P1. So what will bulb rated is P1 and voltage rating for the both the bulbs are same as given. So what will the resistance of the filament of that bulb, first bulb? This will be R1 will be equal to V square by P1, because P is equal to V square by R. So we can write that R1 is equal to V square by P1. Similarly for bulb 2, this will be R2. R2 is the resistance of a filament of the bulb 2, and this will be R2 is equal to V square by P2. And when both the bulbs are connected in series, the effective resistance or the total resistance will be added, R1 plus R2, and this will be, if we take a common V square, this will be 1 by P1 plus 1 by P2, and this will be V square into, I am solving this one, P1 plus P2 by P1 P2. And when series connected, the bulb are connected to the source V. Series connected bulbs, suppose this one is one bulb and this one is another bulb, and both are connected to source, source V. This one is V. And what will the power consumption? Power consumption will be V square by R. R is here the effective resistance of two bulbs. So what will be V square by R? V square by R is V square by total R is here. So V square will be cancelled out, and this will be P1 P2 will be above, that is numerator, and P1 plus P2 will be denominator. So answer will be P1 P2 by P1 plus P2. This is very conventional question. Next question we will discuss. Next question is question number 48. Telegen's theorem is applicable to option A, linear network only, non-linear network only, linear and non-linear networks, option D, linear, non-linear, passive or active and time invariant network. So here what is Telegen's theorem tells that Telegen's theorem explains algebraic sum of power at any instant in a circuit is 0. So that circuit may be linear, may have linear element, may have non-linear element, may have passive or active or time invariant network. So this is applicable to all type of elements. So here option D is correct. Next question is question number 49. For the circuit given below, the voltage across 1 ohm resistor, where is 1 ohm? Here is the 1 ohm resistor, and what is the voltage across this one? So we will consider, suppose here this node voltage is V. So now we will apply KCL, Kirchhoff's current law at node V. At this point we will apply KCL. So what will be the current? Suppose here current is 4 minus V by 3 plus, here suppose here is 0, and here 0 minus V by 1, this one plus 1 here is given current source. So here this is 0, and if we solve this one, 4 minus V minus 3V plus 3 is equal to 0, and again this is 7 minus 4V is equal to 0, and V is, we are getting 7 by 4 volt. So here option A is correct answer. Next question is, in the following circuit, current I1 and I2 are respectively. So here I1 is given and here I2 is given, and asking for both the values. So what we can do here, a current source along with a resistance in parallel, and we can convert this one to a voltage source in series with the same resistance. So this will be converted like this. This will be converted like this. This will how? This is 10 ampere into 5 ohm. This will be 50 volt. This will be 50 volt, and the resistance will be same, that is 5 ohm. 5 ohm. Now the other circuit parts are same. Only this part is changed. Now we can apply KCL at node V. Here I am taking V and we will apply KCL. So now 50 minus V. Here 50 minus V by this one plus this one. That means 10. That means 10 plus, like the previous question, here is 0 minus V by 20. 0 minus V by 20 plus 100 minus V by 30 is equal to 0. And we will solve this one. 6 into 50 minus V minus 3V plus 2 into 100 minus V is equal to 0. And this will be again 300 minus 6V minus 3V plus 200 minus 2V is equal to 0. And we are getting V will be equal to 500 plus 11 volt. This is the voltage at this node. This is the voltage across this node. As we are getting this voltage, we can find out I1 and I2 also. So what will be I1? I1 will be 50 volt. This one minus this volt. 50 volt minus 500 by 11. What is the V by 10, which is equal to 0.4545. And now I2, what we have taken? I2 is in this direction, so we can take in this direction to be the minus I2. So minus I2 will be equal to 100 minus 500 by 11 by 30 is equal to this much. That is I2 will be minus 1.8181. So here answer is option C, that is 0.4545 ampere minus 0.4545 ampere, and I2 is minus 1.8181 ampere. So here is the answer, option C. So next question number 51. Question number 51 is given that for the following circuit, the power delivered by 2 volt source is given by. So here is the 2 volt source, and we have to find out how much power this voltage source is delivering to the whole circuit. So to find out the power delivering by this voltage source, we have to find out how much current is coming out from this source. So then this will be voltage into current, this will be power delivered by the source. So we have to find out this I. So what we will do? Current through 1 ampere source. Current through 1 ampere source will be this source, because across this voltage will be 2 volt. The same voltage, this one, 2 volt. So what will be the current? Here the current will be 1 ampere, because 2 ampere, because 2 volt by 1 ohm, 2 ampere. Next, here 2 ampere and here 1 ampere. Here also 1 ampere. So now I will apply here the KCL. What will be the KCL? I, here small I, capital I we have to find out is equal to small I minus 1, because here 1, small I is this one, so here this will be 2 minus 1, which is equal to 1 ampere. 1 ampere is flowing out of the voltage source, that is 2 volt. And what will be the power delivered by that source? This will be 2 into 1 watt, that is 2 watt. So here answer is option B. Next question is 52. 52 is given that in the network theorem in the network shown below, what is the current I in the direction shown? So here we have to find out the current here. Here we have to find out the current in the direction given. So what we have to do here? We can solve this question in many methods. I have used here the superposition principle. How this can be used? So first, when only 10 volt is active, that means this one is active and this one is inactive. Means current source. This one is current source. So current source inactive means current source inactive means this one is open circuited, this one is open circuited, this one is open circuited. So as this is open circuited, I can write that here this one plus this one in series with parallel 1 is the total resistance. So what will be this one? 1 parallel 5, 5 is 4 plus 1 5, 4 plus 1 5, so this will be 5 by 6 ohm. Current from the source, this current will be 10 by 5 by 6, 10 by total effective resistance. This will be 12 ampere, So what will be the current through this one? This one is the 12 ampere is the total current into opposition here is the 1 by total, opposition by total here is the 1 plus 4, that is 6. So this will be 2 ampere. 2 ampere is when only 10 volt is active. So I am writing it to be I1. So when 10 ampere source is active, now 10 ampere source is active, and we have to omit that this one. So voltage source is 0, that means voltage source is 0 means this is short circuited. Here this one will be short circuited. As this is short circuited, this 1 ohm resistance will have no value. So this is shorted already. So what will be the current? Current is 10 ampere, current is I2, this will be 10 ampere, this is 10 ampere, I2 will be in this direction, so I am taking it to be negative. So this will be minus 10 into opposition is 1 and total is 5, so this will be minus 2 ampere. So if we add both the values I1 plus I2, I1 is when 10 volt source is active and I2 is when 10 ampere is independently active. So what will be the total? Here is plus 2, here is minus 2, this will be 0 ampere. So here answer is 0. Next question is question number 53. Replace the below shown circuit by a single voltage source with an impedance. So here the AC network is given. Here 3 sources are given having different angles and same magnitude, that is 1, and different impedances. First one is having resistance of 1 ohm, second one is J1 ohm, that is inductance, and third one is minus J1 ohm, that is the capacitance. So how we can replace by like this, this one will be the voltage source, voltage and angle, this one will be Z. So what will be the equivalent we can give by Milliman's theorem. So what is the Milliman's theorem? V is equal to V1y1 plus V2y2 plus V3y3. What is Y? Y is the admittance, which will be equal to 1 by impedance. So here V1 is 1 angle 0 plus multiply y1 is 1 by 1, here is the Z1, so this will be 1 by 1. So now V2 is 1 angle 90 into 1 by 1 angle 90, here is the 1 angle 90, Z2 is equal to 1 angle 90. What is Z3? Z3 is 1 angle minus 90, so here this one is the V3 and here this one is the Z3. 1 by Z3 is equal to Y3 and by Y1 plus Y2 plus Y3, Y1 is equal to 1 plus Y2 is 1 by 1 angle 90 plus Y3 is 1 by 1 angle minus 90, and this will result 3 volt. So voltage we are getting, this one is 3 volt angle 0. And what will be the Z? Z is simply 1 by Y1 plus 1 by Y2, 1 by Y1 plus 1 by Y2 plus 1 by Y3. So this will be, this one is like this, 1 by Y1 plus 1 by Y2 plus 1 by Y3. So this will be again 1 ampere. So 1 ohm. So answer will be 3 volt 1 ohm. Next one is what are the Thevenin's equivalent voltage Vth and resistance Rth between the terminals A and B of the following circuit? So here the circuit is given, and asking for here the what will be the VTH and RTH. So for VTH, for for we have to calculate RTH. First, RTH will be, this will be connected, this will be 0, this will be 0, and we have to calculate RTH. RTH will be R1 plus R2 parallel R3, R1 plus R2 parallel R3. But here what is the problem? R1 value is not given in the question, so we cannot calculate this one. That is RTH we cannot calculate. Again, what will be VTH? That is Thevenin voltage. Thevenin voltage will be voltage across R3. So what will be Thevenin voltage? 100 volt into 120 is this one by total resistance. Total resistance is R1 plus R2 plus R3, and here R1 is not given. So VTH also cannot be calculated from this question. So here nothing can be chosen from these options because one value is not given here. This value is not given. Suppose we want to calculate what should be the R1 value. This is not the part of the question. Here this question is wrong, first thing. And if R1 is 68 ohm, R1 is 68 ohm, then RTH will be 168, that is R1 plus R2, 168 parallel 120, that is R3. This will be result 70 ohm. This will be result in 70 ohm. And again VTH will be 100 into 120 by 68 plus 100 plus 120. And here the answer will be 41.67 volt. So here answer will be option D only if R1 is given to be 68 ohm. Because how I have calculated, I have taken this volt and find out what will be the resistance, this one, what will be the resistance R1. So for this question there is no answer because R1 is not given. What should be R1 in the question? Question should be 68 ohm. Next question is question number 55. What is the value of resistance R which will allow maximum power dissipation in the circuit? So here this one is the load resistance and this whole is the source circuit. So what will be the maximum power dissipation in the circuit? For this one, for maximum power to be transferred to R, what will be source resistance? Source resistance will be equal to the load resistance. So here load resistance is not given, so we have to find out what is the source resistance. For source resistance calculation, we have to find out what is the Thevenin equivalent of source part. So for Thevenin equivalent, we have to make this voltage source to be 0, that is shorted, and we have to find out what is the equivalent resistance. And for equivalent resistance, here 20 ohm is parallel with 10 ohm, and then series with 5 ohm. So this will be 20 into 10 by 30 plus 5, and this is 11.6 ohm. That is option number A. Option A is the correct answer, for which maximum power dissipation will occur in this circuit. Next question is a unit step. So next question is a unit step voltage U of t minus 5 is applied to RL network as shown below. The current is given by. So here V is U of t minus 5 and here resistance is R1 and L is given 1 Henry, and what is the current through the circuit. So here we will calculate like this. Vt is equal to RIT, here is the I, and IT is the function of time, plus L di by dt, voltage across the inductor. And if we take the Laplace transform of both sides, Vs will be equal to RIs plus Ls into Is. So Laplace transform of Vs, which is given to be U of t minus 5, is equal to e to the power minus 5t by s, which is equal to 1 into Is, 1 into 1 plus s whole taking common Is, and this will be Is will be e to the power minus 5t by s into 1 minus is into 1 minus is. So this will be, if we take the partial fraction of 1 by s into 1 plus s, this will be 1 by s minus 1 by s plus 1 into e to the power minus 5t. So it will be u of t minus 5 minus e to the power minus t minus 5 into u of t minus 5, and this will be, if we take common u of t minus 5, this will be 1 minus e to the power minus t minus 5. So how this is coming? Suppose we will omit this one and we have only this one. So what will be the Laplace inverse? What will be the Laplace inverse? This will be for 1 by s, this will be u of t, and for 1 by s plus 1, this will be e to the power minus t u of t. And when e to the power minus here this will be s, here this will be this one is s, this one is s, not t, this is in s domain, so this will be s. So when s is multiplied, e to the power minus 5s is multiplied, so when e to the power minus 5s is multiplied, there will be a time shifting. And what will be the time shifting? Time shifting will be like this. Time shifting will be like this. Time shifting will be like this. At the t we have to put t minus 5. At the t we have to put t minus 5. So this will be the answer. This is very simple thing. Next question is 57. In the circuit shown in the given figure, switch S is closed at t is equal to 0. T is equal to 0. The current through the capacitor will decrease exponentially with a time constant. What will be the time constant in this circuit? This is asking. So for time constant, when circuit is being closed, so what will be the time constant? Suppose circuit is being closed, now circuit is closed and switch is closed. For time constant, RC circuit time constant formula is RC, R into C. So what is the R? R is the equivalent resistance or the Thevenin's equivalent resistance of the circuit. So what will be equivalent or Thevenin's equivalent circuit? If we calculate the Thevenin's equivalent circuit, we have to make that voltage source to 0. So we have to make that voltage source to 0, and here this voltage, this 1 ohm will be short circuited and only 1 ohm is remaining. So this will be the RTH. RTH is 1 ohm. And what will be the tau? Tau is equal to R into C. R is 1 ohm and C is 1 farad. So this will be 1 into 1, that is 1 second. So if we calculate by Laplace transform method, so what will be this one? 10 by S. 10 is the voltage source. 10 by S is equal to Is, that is the current, plus 1 by S into Is. 1 by S into Is. So this will be, here I is the current through capacitor, here I is the current through capacitor. Here the symbol is given wrong. This one is capacitor symbol, here given like a voltage source symbol. So this is a capacitor symbol, and here current through the capacitor is Is, and this will be 1 by S into Is. 1 by S is 1 by S into 1 because capacitance value is 1. So what will be the Is? Is is equal to 10 by S plus 1, 10 by S plus 1, and It will be 10 into e to the power minus t. Minus t means e to the power minus t by tau. That means tau here is 1 second. This is the for, and here tau we are getting 1 second. Here option B is the correct answer. Next question is, in the below network, S is closed for a long time till steady state is attained. S is open at t is equal to 0. What are the values of voltage V at t is equal to 0 plus and t is equal to infinite? So at t is equal to 0 minus, that means before opening of the switch. Before opening of the switch, that means switch is already closed. Switch is already closed. So here what will be the voltage across capacitor? Voltage across capacitor will be when switch is closed, capacitor will be open circuited, and what will be the voltage across that capacitor? this current 2 ampere will flow through this one, and the voltage will be 2 into 4, that is 8 volt. So at t is equal to 0 plus, that means just after the switch is opened, now switch is open, so voltage across 4 ohm, this one voltage across 4 ohm will be here we have already found that v zero minus is equal to 8 volt. So what will be v0 plus will be same, that is v0 plus will be also 8 volt. So what will be the voltage across this one? Voltage across this one will be 8 into 4 by 4 plus 4, 8 into 4 by 4 plus 4. So this will be 4 volt at t is equal to 0 plus. So what will be the voltage across 4 ohm, this 4 ohm voltage, 4 ohm resistance at t is equal to infinite. So what will be this one? At infinite, capacitor will be again open circuited, and the whole current will flow, 2 ampere will flow through this circuit. So what will be the voltage across this one? This resistance into that current, that is 4 ohm into 2 ampere, that is 8 volt. So what are the answers? Answers are 4 volt and 8 volt respectively at t is equal to 0 plus and t is equal to infinite. So here option B is the correct answer. Next question is question number 59. For the given circuit shown in the figure below, the initial inductor current and the voltage across the capacitor are 0 and 2 respectively. 0 and 2 respectively. What are inductor current and voltage across capacitor? When the switch S is closed at t is equal to 0, the value of V and the dV by dt are respectively. So here V is given and dV by dt, what value of dV by dt. So now given that this inductor has initial value of a current 0 and this capacitor has initial value of a voltage 2 volt. This is given in the question. So we have to find out what is the V. At when the switch S is closed. So at t is equal to 0, L is open, because this will oppose the current, the sudden change in current. So when when switch is just closed, L, that is the inductor, will be open circuited. So V is equal to voltage across the capacitor. So this voltage will be same as that of this voltage. So this will be 2 volt, simply the 2 volt. So now next, current through R will be 0.02 by 0.25 ohm, which is equal to 8 ampere. So now 8 ampere is the initial current, in this direction, So I is equal to minus C dV by dt. Why minus? Because the capacitor is discharging. So dV by dt is equal to minus I by C, and this will be equal to minus 8 by 2 farad, which is equal to minus 2 volt per second, minus 4 volt per second. So here option A will be the correct answer. Next question is question number 60. For the circuit as shown, what is the value of C that leads to maximum power transfer to the load? If the value of L is 0.5 Henry, if the value of L is equal to 0.5 Henry, so here given this one is load is given, load values are given, and here this one is the source part, and we have to find out what will be the value of C for maximum power is to be transferred to the load. So now load is given to be 5 plus j omega L, and omega here this is given 10 cos 10t. So omega is 10. Omega is 10, 5 plus j 10 into 0.5. So this is 5 plus j5 ohm. ZL is 5 plus j5 ohm, and for maximum power is to be transformed, ZS, that is source impedance, will be the conjugate of load impedance. So as a source impedance is given this one, we have to find out the load impedance is to be 5 minus j5 ohm, 5 minus j5 ohm. So now what is the source impedance? Source impedance is this one parallel this one. So what will be the value? Xc here will be 1 by 10. 10 is the omega, and c we have to find out. So what will be the parallel value? 10 into xc by 10 minus 10 plus xc. So this value, if we solve, this will be like this, and we have to multiply 100c plus j both in numerator and denominator. This will be minus j 1000c plus 10 by 100c square plus 1. And if we separate the imaginary part and real part, this will be like this. And we have to equate to our first values. What is the values? Value is 5. Suppose we are equating the real part, then this will be 10 by 100c square plus 1 is equal to 5. And if we solve this one, c will be equal to 0.01 farad. So here answer is option B. So here next question is question number 61. In a series RLC circuit excited by a voltage E is equal to capital E sin omega t, where LC is smaller than 1 by omega square. So here given that LC is smaller than omega square, omega here is the angular frequency. So if we take square root of both sides, then this will be root over of LC is smaller than 1 by omega. And if we take 1 by root over of LC, this will be greater than omega, because suppose we are taking 3 is smaller than 5, and if we take 1 by 3 will be greater than 1 by 5. So like this, 1 by root over of LC will be greater than omega. That means 1 by root over of LC is the resonant frequency of that circuit. So here what is we are finding out, the frequency, operation frequency is smaller than the resonant frequency. So below the resonant frequency, here is the plot how XL, XC and R are varying with respect to omega. So here this one in the orange color gives the Z is equal to XC. As XC is equal to 1 by omega c, this is the hyperbola. This is the hyperbolic rectangular hyperbola. And as XL is equal to omega L, so Z is equal to omega L is a straight line coming through the origin, and R is the constant value, so this is Z is equal to R. And where the crossing the intersection of XL and XC line gives the omega R, that is the resonant frequency. So below omega R, that means like in this side, XC denominates both R and XL. So below the resonant frequency, the circuit will behave as capacitive. So when omega is smaller than omega R, circuit act as capacitive. That means XL greater than XC is greater than XL. So as this one is capacitive, the current will lead the voltage. So option B here is the correct answer. So next question 62 is, in a series RLC resonant circuit, which one of the following gives the impedance at lower and upper half hour frequencies respectively? So here taking reference from the previous question, I have given the plot of the current in series RLC circuit. Current varies like this. The current will be maximum at resonant frequency. Then in the both side of resonant frequency, here 1 by root 2 value of that current is called the half power frequency. Here I have taken in the same line, that is here. So below resonant frequency from the previous figure, from the previous question, we are getting that from below resonant frequency this is capacitive, and above resonant frequency this is inductive. So why this is called, first why this is called half power frequency, we will explain why this is called half power frequency. This here current is 1 by root 2 times, or this is also called the 3 dB frequency. This is also called cutoff frequency. F1 and F2 are lower half power frequency or 3 dB frequency or cutoff frequency. Similarly, F2 is upper cutoff frequency or half power frequency or 3 dB frequency. In previous videos I have already explained this why this half power frequency is called and why this is 3 dB frequency. So I am explaining again this one, why this is called half power frequency. So at omega r, that is resonance, P is equal to V into I into cos 0, because at resonance XL is equal to XC and only the resistance part will comes into the picture. So the circuit will act as pure resistive circuit. So at that time theta is equal to 0, so I can write that P is equal to V into I, which is equal to V into I max, because at resonant I current is the maximum value. At omega 1, that is below the resonant frequency, we are taking that half power frequency. Half power frequency means we have to take power to be half. As power is half, then what will happen, V into I by root 2, because at that time at that place current is 1 by root 2 times the maximum current, 1 by root 2 times the maximum current, 1 by root 2 times the maximum current. So 1 by root 2 times the maximum current into 1 by root 2, because this is half power frequency, we have to multiply 1 by root 2 only to make this one P by 2, only to make this one 1 by 2. So what will be this one, V into I by root 2. What is 1 by root 2? 1 by root 2 is cos 45. So angle here is 45. Angle here is 45. Similarly, in case of omega 2 is the upper cutoff frequency. That is here also P by 2, and here the expression is same, and here angle is also same. But here this one is capacitive, and here this one is inductive. As this one is capacitive, the current is leading, that is current is I by root 2 plus 45 degree, and at omega 2 this will be I by root 2 minus 45 degree, and this is inductive. So what will be the impedance? Impedance will be here I have written at F1, I have F1, this is leading and this is lagging, or this one is capacitive or this one is inductive part. So here I max by root 2 angle 45, here I max by root 2 angle minus 45. What will be the impedance? Impedance is V by I. So V is angle of 0 by here is the current. What is the current value? V by root 2 into R, angle is 45, and what is it is coming to be root 2 into R, because what is the IM is the simply V by R is the maximum current. So here Z is coming to be root 2 into R minus 45 at omega 1, that means lower cutoff frequency, and root 2 into R plus 45 at upper cutoff frequency. So at lower minus 45, at upper plus 45, and value is root 2 into R minus 45 plus 45. Option D is the correct answer. Next question is question number 63. In a series RLC circuit, supplied by a source voltage of 125 volt at a resonant frequency of 220 Hz. The magnitude of the voltage across the capacitor and the inductor are found to be 4150 volt. If the resistance of the circuit is 1 ohm, then selectivity of the circuit is. So here what is given, voltage across capacitor and inductor is same, that is 4150 volt. Supply voltage is 125 volt. So during resonant, voltage across L and C are in phase opposition and will be of same magnitude, and so they will be cancelled out. So what is selectivity? Selectivity is equal to quality factor, which is equal to voltage across C by voltage across R, or which is equal to voltage across L by voltage across R. So this will be voltage across C and L is given to be 4150 by 125, and this is coming to be 33.2. So this is option A. Next question is given, the driving point impedance function s square plus 2s by s square plus 2s plus 2 by s square plus s plus 1 may be realized by. So driving point impedance function is given here, so we have to find out what type of network this one is. So here we can find out by two methods. First is pole zero method. I will explain in the in another example what are the pole zero method, and here I am explaining the method in which we can explain this one. We can make the circuit, we can design the circuit itself coarse form, in the coarse fast form. So here in the coarse form, the circuit is designed to be series parallel ladder form, series parallel ladder form. So first element will be the type of a function. So here function is given to be ZS, that means impedance. So first element, that is a series, will be of impedance. The next is total number of element will be pole plus 0. So what will be the number of poles plus 0? Here pole is, number of poles is 0, number of 0 is also 0. Number of 0 is 2, here 2 and here 2. So there will be 4 number of elements. So next is, if it is coarse fast type circuit, then L will be in series and C will be in parallel, and continued fraction expansion descending order of both S in numerator and denominator, here also in descending order. That means here power is 2, here power is 1, and here power is 0. We will see another question which have the ascending order. If this one is ascending order, then this is a type 2. That means L is parallel and C is in series. So here we will draw the circuit, and we draw the ladder circuit, series parallel coarse fast type circuit. So to draw the circuit, we have to form the continued fraction expansion. First, continued fraction expansion, how we can do that? We have to divide the numerator by the denominator. So here I am dividing this one. Here if I multiply 1, this will be s square plus s plus 1, and what is the remainder? Remainder is s plus 1, and we have to again divide this one by the remainder. So I have taken this one like this, and again I will divide this one, and again if you divide this one is s, and we are finding the remainder 1, and again we have to replace this one to this. So here this will be s, and similarly here this will be 1. So now what we are getting, Z1, this will be in series, this will be in parallel. Always parallel elements are expressed in terms of admittance, Y2, and this is in series and this one is in parallel. So total here impedance function will be, first one is Z1 is given to be 1 means this is resistance, and second is given S in admittance form. So what will be the Z2 will be 1 by S means here C is the capacitance, S is in denominator means this is capacitance, and what is the capacitance value? Capacitance value is 1. So here Y2, and capacitance value is 1 farad, and then Z3 is given to be S, Z is S means inductance, and what is the inductance value? 1 Henry, and next is Y4 is 1, means Z4 is also equal to 1 means resistance. This is resistance. So what are the circuit components? L, R, C, all are present. RLC network. So here answer will be none of the above. Next question. Question number 65. The driving point impedance ZS of the circuit shown below. So what will be the driving point impedance? That is ZS given. So what will be the driving point impedance? These two are in series. These two are in series with parallel this one, then again with a series. So I will first represent the respective Laplace transform of the values. Then we will calculate the impedance value. So first, this one is S inductance and this one is 1 by S, and both these are in series, and with parallel with 1 by S. This is the capacitance, and again series with S is the inductance. And if we calculate this one, I am not explaining this one how I am calculating. So we will find that to be S4 plus 3S square plus 1 by S cube plus 2S. So here option A is the correct answer. Next question is, what are the poles and zeros of ZS of the circuit given below? So here also we have to find out first the ZS. We have to find out the ZS. So here this is 1 by 9. This will be 1 by 9S. 1 by 9S. Sorry, 1 by 9S, not 1 by 9S. This will be 9 by S. 9 by S in the Laplace form, because capacitance is represented by 1 by CS. C is 1 by 9. So 9 will be in the numerator and S will be in the denominator. So now ZS will be this total term is series with this one. Again this total will be in parallel with this. So now if we calculate this one, this will be 2 parallel of 1 plus 3 parallel of 9 by S. So if we calculate this one, I am not calculating here, I am explaining here this one. If we want to take a screenshot, then what we are getting, 2 into S plus 12 by 3 into S plus 6. So what are the poles? Pole is minus 6 and 0 is minus 12. Pole is minus 6 and 0 is minus 12. Pole is the root of denominator and 0 is the root of numerator. So here answer is B is equal to minus 6 and minus 12. Option B is the correct answer. So here next question, we will go for the next question, 67. Next question is 67. For the two-port network shown below, what is the voltage transfer function V2 by V1? So what will be the voltage transfer function V2 by V1? So voltage across V1 is the voltage across this one, which is equal to the voltage across this also. So I can write that voltage across 4 ohm resistance, this one is equal to the voltage across both 2 Henry and 1 farad. So I can write that one also. So now let V1 is equal to IS into, IS is the current. Suppose this one is IS, then what will be the voltage? Voltage will be IS into 2S plus 1 by S. 2S is this one and 1 by S is this one. So what will be V2? V2 will be simply the voltage across that capacitance. That is 1 by S. So IS into 1 by S. So V2 by V1 is equal to 1 by S by 2S plus 1 by S. And answer will be 1 by S plus 2S square. Here is the answer. So option C is the correct answer here. Next question is, in the first core network with a pole at infinite, the first element must be. So here in the first core circuit, I have already explained what is the first core element, that is series parallel, and first core element, if there is a pole at infinite, that will represent a 0 at finite value, and this will be 0 at finite value means series inductor. First element will be series inductor, because numerator will have degree less than denominator, more than denominator, so that denominator into S will be numerator into S. So as here S is multiplying first element, this one first element is always a series, and here S series means this one is Z, and here this will be inductor, this will be series inductor. Next question, question number 69. Question number 69. Which one of the following network represents the coarse second form of the given driving point impedance? Function ZS is given to be 12S4 plus 10S square plus 1 by 6S cube plus 4S. So course second form, here I have already told that in case of course second form, the numerator and denominator will be in ascending order, So ascending power of here this will be descending power, 4 to 1, 4 to here 0, and in the previous question this was in different form. So here in the second form this is not the case, but we have to consider this one in like this. We have to consider this ascending order in the continued fraction expansion. Here this is not given, here this is given like 12s4 plus 10s square plus 1. We have to take that 1 plus 10s square plus 12s4. We have to take like this in case of second form, course second form. So here L is always be parallel, L is always parallel. I have already explained in the previous question. L is always parallel and C is always series. So if we look at the if we look at the options, then what we are getting, L is parallel and C is series, where L is parallel and C is series. So we have only C and D. Two options where L is parallel and C is series. So we have to next find out the value of C and L, so that we can choose which one is the correct answer, C or D. So now we have to go for the continued fraction expansion. So as I have told that we have to write as this one is the second form, we have to write this one in ascending form. Ascending form means from 0 to maximum value. So here 1 plus 10s square plus 12s4 is divided by the denominator. Denominator is also in ascending form, that is 4s plus 6x cube. So if we multiply this one with 1 by 4s, so this will be 1 plus 3 by 2. So here our aim is to cancel out the first one. In the previous we have also aim to cancel out the first one. Here also we have to cancel out the first one. So if we continue the fraction, as I have already explained in previous question, what we are getting, first one is 1 by 4s, which is Z. First one is series. Series, and as this is 1 by s, 4s, this is capacitor. And what will be the capacitance value? Capacitance value will be 4. Capacitance value will be 4. Capacitance value will be 4. Next is y2. So and this is parallel, and z2 value will be 17s by 8, and this is, as s is multiplied in the numerator, this will be inductor. And what is the value? Value is 17 by 8. And next is 17 by 8, and we can next is 289 by 289 by 12s. This is 12s, not 125. This is 12s, and this is Z3 because series parallel series, that means this one is Z, that is impedance, and as this is one impedance and S is in the denominator, I can represent it like a capacitor, and C will be 12 by 289 farad. And next one is y4, that is parallel part. This is 1 by 24s, and this is 24 S is the impedance part, and S is in the numerator, and this will be an inductor. So what we are getting, the values, first one is so I want to draw this one. First one is capacitor. In series. Next this one is parallel, and this one is inductor. And next this one is in series, and this one is also a capacitor, and its value is 4 farad. This inductor value is 17 by 8s. That means I can multiply it to be 34 34 by 16 Henry. And next this one is capacitor, and capacitance value is 12 by 289, and I can multiply 4 in both numerator and denominator, and I will find it to be 48 by 1156 farad, and next one is last one is inductor. Last one is inductor, and its value is 34 Henry. So we are getting what we are getting here. Here we are getting this one is the answer, because this one is the 34 by 16, this one is 48 by 1156. As we have already get, this one is 34 by 16 and 48 by 1156. So next question number 70. The driving point impedance Zs of RC network is given by Zs is equal to a square plus 4s plus 3. If it is realized in the first Foster's form, then what shall be the first and last element? So first, here given that first Foster form, like as we have already explained coarse form. In coarse form there are two forms, first form and second form. Here also in case of Foster form there are first form and second form. So we have to explain what is the first element and what is the last element. So this will require more space, so I have solved this one in the lower part. So what is the Foster form? So first Foster form is in first Foster form we will use LC realization, and this will be series combination of parallel LC networks, as this is series combination. Suppose series combination means, suppose I will write R plus SL plus 1 by SC also is equal to SL plus R plus 1 by SC. So in terms of series, connection, we cannot say that this one is first, this one is second, because if we alter the values, suppose this will be first and this will be last, there will be no change in the impedance, because this is series connection. So we cannot comment on first and last element in case of Foster's first form. So in this question, this is given wrong, that use first form to Foster's first form to find out what is the first and last element. And another case is Foster's first form is generally used for LC realization. So how? I have already explained that we can explain this one by pole zero drawing. So if we have the ZS is the impedance, driving point impedance, we have driving point impedance ZS, and if we find out the poles and zeros, and we are getting pole at origin, then alternatively 0 pole 0, then go for coarse realization, and this is RC realization, ZRC or YRL form. This is ZRC, that means capacitance resistance will be present, or in terms of Y, inductance and resistance will be present. So this is and another is 0 at origin, then pole, then 0, then pole alternatively. And for this one, this is ZRL realization, and we have to go for coarse realization, as I have already explained in previous two questions. These two, if pole 0 realization is like this, if pole 0 presentation is like this, that means on the imaginary axis, what may be the values, what may be the order, we have to go for Foster's form, and this is LC realization. So look at the question here, what is given in the options: resistance, capacitance, resistance, capacitance. So here LC is not given, so Foster's first form cannot be used here. We have to use here the coarse first form to find out what is the first element and what is the last element. So for that one, we have to go for that C continued, that is C continued fraction expansion, CFE, continued fraction expansion. Before that one, I want to explain coarse ladder network. In this equation I have already given that this is RC network, because here what are the poles? Poles are here 0 and minus 2, 0 and minus 2, and 0, if we expand this one, this will be minus 1 and minus 3, and here 0, 1 pole, another 0, pole 0. So as this is as I have already explained here, pole at origin means this one is ZRC circuit, and we have to go for coarse realization. So here this will be ZRC circuit, and we have to go for coarse realization, and we have two type of coarse realization. Not in terms of first and second, like first, what will be the first term is series or first term is parallel. We already know that in many cases first term will be series, series parallel form. But if we put z is equal to infinite, and we will get 0 value for zs, then this value will be, the first element will be parallel. Remember this one, first element will be parallel element if zs at s is equal to infinite will be 0. And here if we put zs s is equal to infinite, what we are getting, here I am taking s plus 3 s plus 1, and I am taking s square into 1 plus 3 by s plus 1 plus 1 by s, and in denominator also s square into 1 plus 2 by s, and if we put s is equal to infinite, this will be 0, this will be 0, this will be 0, and this will be cancelled out, and answer will be s at s is equal to infinite, zs will be 1, that is non-zero. Non-zero means first element is series, so circuit will be like this, ladder circuit will be like this. So we will use coarse fast realization form, and we will go for the continued fraction expansion. So like previous one, I have already done the coarse fast realization, and I have already drawn the circuit. If you want to analyze it, please take a screenshot. So here what we are getting, first element is resistance, that is 1 ohm, and last element we are getting capacitance. So we will go to the question, and here question first one is resistance and last element is capacitance. So here option A is the correct answer. Next question is, what type of filter produces a predictable phase shift characteristic in all frequencies? So in all frequencies, that is all pass filter. Answer is all pass filter. Because here predictable phase shift characteristic in all frequencies. Next is, what is the value of notch frequency if the value of resistance and capacitance are 100 kilo? This is resistance value, so this is not kilovolt, this is kilo ohm. 100 kilo ohm and 0.02 microfarad. So what is notch frequency? Notch frequency is nothing but the cutoff frequency, and here RC is given. So it may be a low pass filter or high pass filter, but the cutoff frequency formula is same, that is 1 by 2 pi RC. And if we put the value of R and C, this will be 1 by 2 pi into 100 into 10 to the power 3, that is 100k into 0.02 micro, that is 10 to the power minus 6, and answer we are getting to be 79.6 hertz. Next question is 73. A balanced delta connected load has an impedance of 9 angle 30 ohm per phase. Per phase impedance is given. What is the impedance per phase of equivalent star? So what will be the star value for balanced delta connected? 9 angle 30 by 3. This is simply 3 angle 30. Option C is the correct answer here. Next question is, a 3-phase 3-wire supply feeds a star connected load consisting of 3 equal resistors. If one of the resistor is to be removed, then what is the reduction in power as compared to the original power? So when 3 resistors are present, what is the phase voltage? Phase voltage is VL by, I am changing the color, VL by root 3. So what will be the power? 3 into V phase square by R. 3 is because this one is a 3 phase circuit. So 3 into V phase square by R. This one is the power, and V phase is VL by root 3 square into 1 by R. So this one is, we are getting VL square by R. This one is the power for first circuit. If I delete one resistance, this resistance I have deleted, what will be the power consumed will be equal to VL square by 2R, because these two resistances are now connected in series. So power consumption reduced by 50%, because here this one is VL square by R and here we are getting VL square by 2R. So power consumption is reduced by 50%. Next question is, here option C is the correct answer. Next question number 75. A three-phase delta connected symmetrical load consumes P watt of power from balanced supply. If the same load is connected in star to the same supply, then what is the power consumption? So here this one is delta connected, and what is the power consumption in terms of line voltage and line current? P delta is equal to 3 into V phase into I phase into cos theta. So 3 into V line, because in case of delta, phase voltage is equal to line voltage, but phase current is root 3 times that of line current. So line current will be the phase current will be 1 by root 3 into line current. So here this will be like this. This will be like this, root 3 into VL IL cos theta. In case of star, V in 3 into V phase into I phase into cos theta, theta will be same in both the cases, as we have already seen in the previous question. Here in the previous question we have already seen that 330, here 30, and here also 30. So angle will be same, impedance angles will be same, but P star, that is power consumption in star connected network, will be 3 into V phase into I phase cos theta, which will be equal to 3 into V line by root 3. Here V phase is equal to 1 by root 3 into V line voltage, and this will be equal to root 3 into VL IL cos theta. And if we see that this and this are equal, so P star is equal to P delta. So here answer will be B. Next question number 56. Fourier series having even function symmetry will contain sine term only, cosine term only, both sine and cosine term, none of the above. So here even function symmetry. So what is even function symmetry? Like this. Even function symmetry is like this: x of minus t will be equal to x of t. That means if we put this value for positive x value and for negative x value, the y value will be same. Y value or f of x value will be same. So this is even symmetry. For even symmetry, DC term does not exist. This is actually in positive half cycle only. If we consider the cos wave, for waves like this one, DC term will be 0, and that is cosine term will also be 0, and only this will not, the DC term will not be 0. Sorry, I have explained it wrong. DC term will not be 0, cosine term will not be 0, but sine term will be 0. Sine term will be 0. So here in the question given that sine term only, not answer; cosine term only, not answer; both sine cosine, not answer. If it is given that DC and cosine terms only, then this will be answer. But here answer will be none of these, because we are getting both DC term and cosine terms, and this is also correct. Next is the Fourier expansion f of t is equal to a0 plus summation from n is equal to 1 to infinite an cos n omega t plus bn sin n omega t of the periodic signal shown below will contain the following non-zero terms. This is one of the GATE question, GATE 2011 signal system question. So OPSC has omitted this one. Here there should be T0, because if we don't take here 20, then answer will also be different. So how we can explain this one? Here look at the plot at positive x value and for negative x value, the y value or the ft value is same. For this one value same, for this one value same, for this one value same, this one value same. So this is even symmetry. Not here half wave symmetry is not seen. This is only even symmetry. In case of half wave symmetry, minus term will be present. Half wave symmetry we will see in the next question. In this case there is no half wave symmetry. So in this case f of minus t0 is equal to f of t. That means this is a even symmetry. So for even functions a0 and an are non-zero. Already explained in the previous question, and n is equal to 1 to 3 from 1 to infinite. So if half wave symmetry is given, then only odd quotient terms will be present. So in case of this, a0 will be present, that is a DC term will be present, because there is no negative terms, and the average, that is a DC term, will not be 0. So a0 will be non-zero value, an will be non-zero value. That means quotient terms will be present, and all 1 2 3 4 5 up to infinite, all the values will be present. And b term, that is sine terms will be absent, because of this function has even symmetry. And here mark this one, here answer will be b, and here mark one thing, here option A and option D are equal. This is one of the mistake. Next question is Fourier series of the waveform ft shown in the figure below. This is also a GATE 2002 signal system question. Here is the waveform, and we have to find out what is the Fourier series. What is the Fourier series? So in this question, this is also an even function, but here we can say that f of t is equal to minus f of t minus t by 2. For this one we have to take an example. Suppose here t is equal to 2, f of t value is this one, and t minus t by 2 means t minus half means 1. For this value this value is this one. That means this is negative of this one. So this case, this is even and half wave symmetry. For even and half wave symmetry, b term, that is sine term, will be 0, and DC term will also be 0, because here negative part, positive part will be cancelled out. Here DC term will be 0, and an is the cosine terms will not be 0, but the odd cosine terms will only present. Even cosine terms will be 0. So here we have to find out where only cosine terms are present. So in option A, sine is present, so this is not the case. Next, in case of option B, also sine present, so this is not the option. Option C, only cosine terms are present. Option D, sine terms are present. So this option D is not the answer. Option C has only cosine terms are present, and here n is 1, here 3, that is odd cosine terms, here is 5, odd cosine terms are present. So option C here is the correct answer. Next question number 79. Consider the function fs is equal to 5 by s into s square plus 3s plus 2, where fs is the Laplace transform of function ft. The initial value of ft is equal to, so we will apply the initial value theorem, that is when f of t has initial value, that is t tends to 0, limit s tends to infinity, s into fs. That is, in terms of Laplace transform, we have to find out like this. So this will be s into given function and s tends to infinite. So s into given function, that s in denominator and numerator will be cancelled out. So this will be 5 by s square plus 3s plus 2. And if we write s square plus 5s plus the 3s plus 2, we can write it like s plus 2 plus s plus 1. And I can take s from both the parts. I can write it 5 by s square into 1 plus 2 by s into 1 plus 1 by s, which is equal to 0. Because when s tends to infinite, this will be 0, this will be 0, and this will be 0, and this will be infinite. This one infinite means this is 0. This is 0. So here answer will be option D. Next question, question number 80. Question number 80. Laplace transform f of t is equal to Laplace transform of f of t is equal to e to the power 2t sin 5t ut. So for sin 5t only, sin 5t ut, we have a Laplace transform 5 by s square plus 2s. 5 by s square plus 5 by s square plus omega square. Omega square is 5 is omega square is 25. And for e to the power 2t multiplied in the time domain, there will be frequency shifting. Frequency shifting means there will be negative minus 2 square, negative minus 2 at the place of s minus s. We have to put s minus 2, and here if we put s minus 2 instead of s, this will be 5 by s minus 2 whole square plus 25, and this will be 5 by s square minus 4s plus 29. So here option A is the correct answer.